In today's opener, I want you to find the measure of angle A in this triangle. Hopefully you've tried this first before you listen to this, because it's no good to just watch, you need to try it. So if you haven't, hit pause and go ahead and try it then. Okay, so now we want to find the measure of angle A. Here's angle A. So how can we do that? Well, if you think about what we've done with triangles and solving triangles, you could think, well, I don't know any of the angles, but I could figure out the lengths of the sides. So I can figure out the length of side AB by doing the distance formula, square root of difference of the x's, -3 minus 3 squared, plus the difference of the y's, 2 minus 10, quantity squared. And simplify that, we get 36 plus 64 is 100, the square root of 100 is 10. So I have the length of this side is 10. Let's find the length of side AC. Once again, you can use Pythagorean theorem or distance formula. And so I know it's 12 in the x direction and it's 5 in the y direction. So here's another way of thinking about it instead of just jumping into the distance formula. And if you remember your Pythagorean triples, 3, 4, 5 was the most common. Second most common is probably 5, 12, 13. So I already know the length of segment AC is going to be 13. Go ahead and verify that if you need to. And then finally we're going to do side BC. So for BC, the difference of the x's, let's put it over here, between 3 and 9 is 6, squared is 36. And the difference between 10 and negative 3 is 13, squared is 169. So this gives us the square root of 205. And we'll just leave it as square root of 205. Okay, so now that we know the lengths of all the sides of this triangle, we can find angle A using the law of cosines. Remember the law of cosines. A squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. And that's the one we want to use. So basically you just have to make sure that the side that's by itself here matches with the angle that's the argument of your cosine. And so that's why I chose to do a squared instead of b squared equals or c squared equals. And then we just plug in our numbers. So side A, here I'll label these. Side A is over here across from A. This is B and this is C. So A squared is actually going to be 205. B squared will be 169. C squared is 100. Minus 2 times B times C is 130. Times the cosine of angle A. And then you just have to isolate angle A. So we'll subtract 169 and 100. That's going to be 105. So a negative 64, I believe. And then we're going to have to divide that by the negative 260. And that will equal the cosine of angle A. So A is going to equal the inverse cosine of 64 over 260. And we'll grab a calculator and we'll check that out. Let's make sure I did these calculations right. 205 minus 100 minus 169. Yep, 64. So we're going to do second cosine. Make sure you're in degree mode. I already checked, so I know I am. 64 divided by 260. Don't waste time reducing that fraction. There's no need to. And we get 75 point, we'll just round it to the nearest tenth. 75.7 degrees. So A is approximately 75.7 degrees. And there's your answer. Now, if you had tried this ahead of time, you might have looked at this and said, oh, I'm not even thinking about solving triangles. So I'm going to go ahead and, well, I guess I'll leave those. Well, let me get rid of these. You might say, well, what if we use vectors? if I found vector AC and vector AB, I could use that formula. The cosine of the angle between two vectors is the dot product over the product of their magnitudes. So let's do that. Let's find vector AB. Remember, that's terminal minus initial. So 3 minus a negative 3 is 6. 10 minus 2 is 8. And then vector AC, which is 9 minus a negative 3. So that's 12. And negative 3 minus 2 is negative 5. All right, so we know that the cosine of the angle between them is equal to the dot product. How do we do that? We multiply 6 times 12 plus 8 times negative 5 all over the magnitude of AB. Well, we already know that. We could have, if we didn't calculate that earlier, we have 6 squared plus 8 squared in the square root. So we get 10 for that. And for AC, well, that's 13. So theta, or I shouldn't call it theta, I should call it A. Let's put A in there so we're not confusing anybody. So the cosine of angle A is that. So angle A is equal to the inverse cosine of 32 over 130. Wait a minute. That's the same fraction. It's just reduced, we just divided out at 2. So I know I'm going to get the same answer. A is approximately 75.7 degrees. So 2 different ways to approach it. One using vectors and one using solving triangles, law of cosines. And that's it.